Alright guys, here we go. This is Math 2, Unit 5, Lesson 2. We're going to look today at some homework help for numbers 1, 5, 10, 14, and 24. That's the goal at least. We'll see how that goes. Alright, I want to begin with number 1 because it does give you some information. It's important. It says to start to find the value of x, identify the relationship between the marked angles in the diagram. The marked angles are consecutive angles, and that's something you want to remember for later on as well. And by Theorem 41, which will help you later on when you start looking at proofs and showing the why behind the what, as we like to say. And as such, those angles are supplementary. What that means is that when I look at these two angles together, they're going to be adding up. Supplementary means to 180. So to give you a little formula here for how you could potentially solve that, you would take the value of x plus the other number in the consecutive angle, 51, and set that equal to 180 because it's going to be supplementary. Then, of course, you solve for the value of x by subtracting 51 from both sides, and x equals 129. You'll do that same type of thing on the remaining problems. If you look here, we have consecutive angles. We don't quite have consecutive, well, I guess we do, don't we? Sorry. We do have consecutive angles going this direction too. It's the same idea, just going a different direction. And then we have consecutive ones here as well. So you'll use the same type of setup for those problems. When we go down to number 5, I notice on my form here, there is a little typo. If you're already confused, what's going on? I believe this should be DG right there. I'm not sure why it says C, but it printed off as a C on mine at least. And what we know in a parallelogram is that the opposite sides are going to be congruent. So while I don't know the actual length, I do know that this length here is going to be congruent to this length here, just as the top length will be congruent to the bottom length. I can't determine whether or not they're all equal to form a rhombus, or I mean, it's not a square because it's not right angles, because I can't tell the information that's given. So to determine number 5, it wants to say what are the variables in D, E, F, and G. So when I look at this one here, I have a lot of information, a lot of which I don't actually need if I think about it, because if I know that DG equals the opposite side, EF, then I take a look at, then I take a look at the information they give me. DG is equal to 2x plus 2. I write that down. And that's going to equal my EF value of 3x minus 3. And then all I have to do is solve for x. So I'll subtract 2x from both sides. And I'm left right now with 2 equals 3 minus 2 is 1. So we just write x minus 3. I'll add 3 to both sides to determine that, indeed, 5 equals x, or x equals 5. I could check that also by looking at my DE and GF values. Again, we said that DE equals GF, and I could do the same thing on that side and say, all right, let's set them equal to each other. 3x plus 1 equals 2x plus 6. I subtract 2x from this side, I end up with x plus 1 equals 6. I subtract 1, and what do you know? X still equals 5. So, do I need to do it 2 times? Probably not, because it's going to be the same solution either way. I'll do the same type of thing for number 6 and 7 and 8. When I move down to number 10, I'm still using the Theorem 41 of consecutive angles being supplementary. I can see here I have supplementary angles, or consecutive angles, I'm sorry. So I can set them equal to 180. So I write down 8s plus 5 plus 3s plus 10 equals 180. From here I will combine like terms, and I end up with 11s plus, I have plus 5 and plus 10, so plus 15 equals 180. Subtract 15 from both sides. We end up with 11s equals 165. Divide both sides by 11. And s equals, what do we have here? We have 15. And there we go. So that's number 10 right there. I'm going to go ahead and turn the page, or in your case, flip it over. And I go to the back side of mine, number 14 here. One of the things we did learn about with parallelograms is that when you have a parallelogram, when the angles across the middle bisect each other, what happens is that the two parts are going to be equal, meaning that this line, well, I'll draw a different one for now, this line right here, that chunk right there, will be equal to that chunk right there. So when I want to determine the missing value, I simply have to have this equal to this. So let's take a look at number 14 real quick. I'm looking to solve for j, and so when I look at 14 here, I can say that, alright, this line right here, 4j minus 19 equals, right here, this side, right across, because those two sides will be equal, because they split each other as a parallelogram, 2j plus 3, and now I solve for j. So minus 2j, subtract 2j, so I'm left with 2j minus 19 equals 3. I'll add 19 to both sides. I'm running out of room, I apologize. 19 plus 3 happens to be 19, 20, 21, 22 equals, I'm left over here still with 2j. Sorry that I went a little sideways on you there, but I'm just moving this over there. So I want to get j by itself, divide both sides by 2, and j equals 11. I could do the same thing with the other problems as well. I can set this line equal to that line because, again, it's a parallelogram and they're crossing in the middle. Those are going to be congruent parts. Just real quickly, when you look at this one here, this one's a little crazy when you first take a peek at it. I'll give you a little hint on this one here. We have a lot of parallel lines, and we have these other lines intersecting them at different points here. Because these four lines are parallel, it's going to tell us the distance from one space to the next is going to be equal or congruent. And what I mean by that is that if, for example, this space right here is indeed 5.75, then this space is also 5.75, and this one also is 5.75. So if I have to come to a problem like this one, what is the length of G to J? I would say, well, it's 5.75, and guess what? I happen to have 1, 2, 3 of those. We multiply by 3, 15 times that, 21, 22, carry the 2, 15, 16, 17, and 2 decimals, hop, hop, and 17.25. I could do the same thing also with this side over here. Let's use the regular pen for now. I can see that BC right here is equal to 5. So when they want me to ask me, okay, well, what is C to D? Well, that's also just C to D. It's also 5, and since it's just from C to D one time, it's just simply going to be equal to 5. The other one that looks a little trickier, but it's really not, is this diagonal line, because they give you this distance here at 6.5, but because these lines are parallel, that means that this distance is also 6.5, and don't get confused by the little one there, this distance, A to F, is also 6.5. So when they ask on this case here, A to K, we recognize that we're going 1, 2, 3 lines down, each of which is equal to 6.5. I'll let you do that one on your own. Then when I get to number 24, the last one for today, we have angles that are opposite each other, and these are going to be congruent parts. So all I need to do here is set them equal to each other. 40 equals 3a minus 5. I'll add 5 to both sides, ending up with 45 equals 3a. Divide both sides by 3, and I'm left with 15 equals a for number 24. All right, hope that was helpful. Have a great day.